Alright, next we are going to look into the second sub question. They are asking to show that b equals to 5. Alright, and from the first question we substitute the curve by the x and y value. Okay, and then from the question itself they got one additional information which is the gradient of the tangent is 6. If you remember, the gradient of the tangent of a curve is basically dy by dx. Okay, so first we write down the equation for the curve y equals to negative e negative x bracket a cosine 2x plus b sine 2x. When you look into this function, alright, or this equation, you can observe that it comprises of two different functions of x. Alright, so the first one is e negative x, which is one of the function of x, and the second one is a cosine 2x plus b sine 2x. Okay, alright, so how do we do a differentiation for the product of two functions of x? Yes, we have something called a product rule. Let us recall back the formula. If let's say there's a function, okay, is the product of fx and gx, so how are we going to differentiate it? Okay, so first we will put gx down, and then we differentiate fx term first. Alright, after that you plus with, now we put fx there without any changes, and then differentiate for gx. Alright, so you can look at this equation. Alright, so now looking back into the original equation, we have e negative x bracket a cosine 2x plus b sine 2x. So what I will do is I first put e power of negative x and then differentiate a cosine 2x plus b sine 2x. Okay, then add with the second part, which is a cosine 2x plus b sine 2x, and then I differentiate e negative x. Okay, so then you get something looks like this. Okay, how do we differentiate a cosine 2x? A is a coefficient, so we can't do anything but just bring it down. Alright, differentiation for cosine, we'll get negative sine 2x. Alright, and then do not forget to differentiate the 2x as well. Okay, so 2x, after you differentiate you get 2, then you plus b coefficient, you write down, differentiate sine 2x, which is cosine 2x. Okay, then again differentiate 2x, which is 2. Alright, so what's next? Next we will need to simplify the expression. Yeah, okay, so here I will rearrange, bring numbers to the front. You get negative 2a, this is a negative, this 2 and a, so we get negative 2a sine 2x, and then here we have 2b cosine 2x, plus this one I will multiply a cosine 2x with e power of negative x and b sine 2x with e power of negative x, and you get something like this. Alright, so next again we further expand, and we will get negative 2a e power of negative x sine 2x plus 2b e power of negative x cosine 2x minus a e negative x cosine 2x minus b e power of negative x sine 2x. Alright, so I believe you know how to simplify this. Alright, and then from here what we can do is we can start substituting is the 0 into the x, and the b, sorry, not b, but the gradient of the tangent 6 into dy by dx, right? Okay, so it looks like 6 equals to, alright, you can see here we substitute or replace the x by 0, 0, 0, 0, and then 2x becomes 0, 2x 0, 0, x 0. Alright, and you remember sine 0 is 0, sine 0 is 0, so the first term and the last term you can actually strike it off. Alright, what you left is just the second and the third term. Alright, so I just write it down again. I'll get 6 equals to 2b e power of negative 0 is 1. Alright, cosine 0 is also 1. Alright, minus a, alright, e power of negative 0, cosine 0, both are also 1. Alright, so you get 2b minus a. Alright, so if you remember just now in the first question, alright, we found out that a is equals to 4. So here you just substitute a by 4. You get 6 equals to 2b minus 4. That's we get 2b equals to 10 after that, and b will equals to 5. Alright, so I hope you understand this, and then we will move on to the third part.